Hey folks, it looks like sadly the Kubernetes webinar didn't record, so in this video I'm going to take you through the awesome ways you can use Tailscale with Kubernetes. We'll be talking about the Kubernetes operator and how it can simplify Kubernetes cluster connectivity. By way of an introduction, I'm Lee Briggs, a solutions engineer here at Tailscale. You can find infrastructure as code examples on my GitHub account, as well as short and long form content about Tailscale on my blog and social media accounts. We're going to talk about some Kubernetes concepts in this video that would be good to have some prior knowledge of. An understanding of what an operator is will be useful, as well as some Kubernetes networking knowledge around services and ingresses. If you've used Tailscale before, it will be helpful if you know how to use devices and tags, as well as an understanding of Tailscale's subnet routers. The Tailscale Kubernetes operator has four main use cases which we're going to cover today. It allows you to quickly and easily enable access to control planes and API servers that are in private subnets using an API proxy. It enables exposing cluster workloads to a private, secure network using service and ingress objects. It also helps you design cross-cluster connectivity solutions that would usually require complex network implementations or hard-to-manage service mesh solutions. And finally, it allows you to quickly and easily create Tailscale subnet routers, which are highly available using the connectors CRD. Generally, I don't like these presentations to have a lot of slides, so let's head right into a demo of these features, starting with the Tailscale API proxy. Here you can see my tailnet that has a variety of devices in it, such as subnet routers for my VPCs and some app connectors so that I can route traffic to specific websites. If we scroll down a little bit further, you can see that I've installed the Tailscale Kubernetes operator on 3 Amazon EKS clusters, one in US West, one in EU Central, and one in US East. If we move to the EKS console in AWS and switch to the networking tab, you can see that I've enabled private API server endpoint access here. This means that the API server endpoint is not available on the public internet, which is the EKS default. Having your EKS control plane on the internet means that anybody is able to query it and opens a potential security vulnerability in your organization. So how do we access this cluster? Using the Tailscale configure command, we specify our host name for the operator that's installed in the cluster, which builds a kubeconfig for us that actually uses the Tailscale address for access to the cluster. We can take this even further if we install the Tailscale operator in auth mode. This allows us to use ACLs with the operator that enables to scope access to the cluster. Here you can see the Tailscale ACL grant that allows any administrator of the tailnet access to the system masters group within the cluster. If I comment this out, I lose access to the cluster and all the cluster authorization. However, I've also created an engineers group here with myself in it, and if I uncomment this ACL, which scopes any engineers in the Tailscale in the tailnet access to the engineers group in Kubernetes. What this means is that I lose access to the cluster role binding at the cluster level. However, I do get access to my demonstration namespace. This allows me to be very prescriptive with access to cluster resources without requiring any external OIDC. I've got full SSO access to Kubernetes with a simple install of the Tailscale operator, and I can scope my permissions down to the cluster resource level. Another function of the Tailscale operator is the ability to expose services within our cluster to the tailnet, giving us private encrypted access to Kubernetes workloads. Here you can see I've installed Prometheus in this cluster and created a service of type load balancer with a load balancer class of Tailscale, which you can see here. This creates tailnet devices for these services and allows me to access the Prometheus UI over a secure network with no additional infrastructure like internal load balancers required. Here you can see I can easily access the Prometheus UI, and you can see the tailnet machine that has been added to my tailnet here. This was created by the Tailscale load balancer and the Tailscale operator. I can also create ingress objects with the Tailscale operator. Here you can see I've created an ingress with an ingress class of Grafana. The Tailscale operator has created a device which responds to this address. I can access my Grafana instance over HTTPS, and I automatically get a certificate from Let's Encrypt. If you recall, I created 3 EKS clusters in 3 different AWS regions, and there's a Prometheus instance in all of these clusters. I want to be able to connect these Prometheus instances as data sources to my Grafana instance. I can connect these clusters together using the Tailscale operator. You can see here that I have 3 services of type external name, which correspond to the tailnet devices that are the load balancers for those Prometheus instances in those remote clusters. This allows me to easily create cross-cluster connectivity, and all these Prometheus instances are data sources in my Grafana instance. You can see them here. I can then use these data sources within my Grafana instance and use the dashboards by connecting to each one of those Prometheus instances, which you can see here. This is the data from the Prometheus US East instance and from the US West instance. This is incredibly difficult to do without Tailscale, requiring complex CNI implementations, VPC peering, or transit gateways. You may even have to do this with a service mesh. What about these ingress and service objects is that they just act as Tailscale devices, so you can use them with Tailscale's ACL system and take things like tags into account. Here you can see I've created an ingress for a demo streamer application that will allow these streamer applications to drop when I'm connected to the ingress. Let's take a look at that here. You can see the green dot appears when I'm connected to the tailnet, and this is showing me that I have access to this particular ingress right now. If I go into the access controls and remove the default ACL so that this particular tailnet does not allow access from any device to any device and hit save, you should see pretty quickly that my access actually gets removed from the ingress. I'm just going to quickly remove the other permissive access here. And you can see the circle is now turned red and the streamers stop falling. I can then add a more explicit ACL. So instead of allowing access from all devices to all devices, I've created a group which I call engineers, and I've added myself to it within Tailscale. And then I can specify this group allowing access to a specific tag, in this particular case demo, on a specific port. If I hit save, you should see that very quickly I get access back to this particular ingress. This is just using Tailscale's ACL system, but I can now apply it directly to things like Kubernetes ingress and Kubernetes service objects. This really allows me to be extremely prescriptive in my access to my network. It gives me ZTNA or Zero Trust Network Access features on a very easy level within Kubernetes. Tailscale subnet router features can help me with a common Kubernetes problem, overlapping subnets. In this particular demo, I've intentionally created 3 EKS clusters that have the same service-side block, meaning that if I wanted to connect these service-siders together, I'd have a really hard time due to the overlapping CIDR blocks. I can use the Kubernetes operator to create a subnet router that lives within the cluster using the connector CRD. You can see this on my US West cluster here. You'll notice that I'm actually advertising a IPv6 subnet here. This is using Tailscale's 4 via 6 support to allow me to route overlapping CIDRs. So what I've done is I've created a subnet router that calculates the IPv4 address using a unique site ID for each one of these clusters. This then means that I'm able to access this overlapping CIDR block even though I have a subnet router in each location. And I can do that using the magic DNS address and then adding a via for a site ID. So this is the US West cluster and this is the US East cluster. This is really hard to do without Tailscale support. I've not had to add any IPv6 connectivity to the cluster. The VPC itself does not have any IPv6 connectivity. This is really straightforward and easy to do. And this is just one example of how to use subnet routers in your Kubernetes cluster. You could use subnet routers in a traditional way and just advertise the CIDR block for a cluster or the pod CIDR for a cluster to allow you to access those internal Kubernetes networks without having to do a whole bunch of work. The final feature, which I think is always worth talking about when it comes to Tailscale, is again a more traditional use case. In this particular situation, we're going to talk about Tailscale SSH. I've added Tailscale to all of my EKS nodes and included the SSH feature when I've instantiated the client, which means I can easily SSH to my Kubernetes nodes in case I need to debug any problems. I've also included SSH session recording to enable me to get an activity log of all the actual activity that's happening on this node. This is a really useful feature from a security perspective and an audit perspective. So you can see here, I can simply run nodectl to to be able to see all of the running containers on this node. If you ever have a problem where you are trying to debug things like image pull issues or anything that's actually happening on a running node, this can be a very valuable feature. I think that covers everything that we covered in the webinar, and as I mentioned in the webinar, feedback is really important to me. So here's a QR code for you to be able to provide feedback to us on the contents of this video. And thank you very much for joining us. If you'd like to talk more about your Kubernetes use case at an enterprise level, please feel free to reach out to us at se@tailscale.com. Thanks very much for watching.